Okay. All right, guys, here we go. I'm ready. All right, so you had to solve this for y, right? So we already did this back in chapter 1, and I warned you that we're going to have to solve for y a lot in the next chapter. So it's going to come back today and the next section as well. So what's going to happen is we just spent the entire last week in section 1 working with functions and learning what it means to be a function. And we can definitely say that to be a function, you are defined by an equation where when one number goes into it, only how many numbers can come out? 1. That's what it means to be a function, right? So now that we know what it is to be a function, now we're going to spend the next, I would say, couple chapters working with a very specific kind of function. We're going to start working with linear functions, and you have already worked with them in Algebra 1. How many of you remember y equals mx plus b? Everybody does. I feel like it's the one thing in math that you guys always remember. Well, guys, guess what? Y equals mx plus b is a linear function. It's a linear equation. So we're going to spend the next chapter or two working with those kinds of equations. So the good news is they're very easy equations. They're very basic. It's as easy as a function will ever get. If you guys remember when we were working with functions and you had to find f of 2 or f of negative 3, that was only as hard as the rule that you had to plug it into. So when there were x squareds and minus 4x and plus 7, then yeah, that got a little bit harder. But when it was nice, linear, y equals mx plus b type equations, those were as nice as it ever got. So we're going to work with really nice functions. So guys, if you don't know it already, this is y equals mx plus b. That by definition is a linear function. This is a linear equation as well by the definition. So we're going to be working with these types of equations. Nice and easy. All right, let me give you your notes. And then, like I said, hopefully it'll go pretty quick. I'd love to see you be able to get your homework done. Nope. And guys, this is another section where you ain't going to do a lot of math. So I know you guys like that.
Oh my God.
Maybe that's
I was doing so good today.
No.
And then I go to history, and she puts on a video.
Well, to me, that's harder. You had to understand the concept.
She put on a video and it's like, oh my God.
Okay. All right, so here we go.
What do we have tomorrow? I don't know.
All right, so guys, we are going to be working with either a linear equation or a linear function. Really, it just comes down to whether or not they use y or f of x. If they use y, we call it an equation. If they use f of x, we call it a function. But at the end of the day, they are linear. So what does it mean to be linear? By definition, an equation or function that can be written in the form good old y equals mx plus b, or if you use f of x instead, f of x equals mx plus b. If you are an equation that can be written in that form, then you are a linear equation, a linear function. All right, so we can also say, by its definition, that if you are a linear equation or function, then it is a degree 1 equation or function. So what does it mean in math when we call something degree 1? That means the highest exponent, power, on a variable is 1. So guys, it's the best. If you're going to have a variable x, it's just going to be x. The exponent on it has to be 1. If you're going to have y, the exponent on it has to be 1. The highest exponent in a linear equation on any variable is 1. So that means you don't got to use any x squareds. You don't got to have any x's to the third, making this more complicated. It's as easy as it gets. It's degree 1. All right? And then another thing to know about a linear function or equation, the graph of any linear equation or function will always make a straight line. So if you are looking at a graph and it's a perfectly straight line, then you already know the equation that goes with it is a linear equation. The word line is in the word linear. They make straight lines. And the reason they make straight lines is because, guys, their equations aren't complicated. They're really easy, basic equations, okay? All right, so if that's what it means to be a linear equation, I just want to give you guys a few ideas that can't be a linear equation. Just keep thinking to yourself, I want it to be easy. I want it to be basic. So if there is multiplication between variables, like 2 times x times y, I don't want to multiply variables together. That gets a little too complicated. I don't want -3 times x times z. I don't want that. And if you're looking at this as mx, well, isn't that multiplying variables? Guys, m will always be replaced with a number, like y equals 2x plus 3. M is always going to be given to you as some constant number that they use in the function. So if they are multiplying variables together in the function, that's not linear. There are no variables allowed in the denominator, okay? If you're going to take a number and divide it by x, divide by the variable, no go. That is not basic. That is not easy. That's not linear. And then last, if they're going to give you a radical, like a square root, if they have variables underneath that square root, that ain't easy. That's complicated. That's not linear. So these are the type of operations you want to look for. They should not be in that equation. If they are, it couldn't possibly be classified as linear. Go ahead, Brendan.
For b, it says x to the third power. Is that multiplying by
X to the third means x times x times x. That's a third power. That's an exponent of 3.
But does that mean it's multiplying by, wait, yeah, does that mean
it's multiplying x by itself 3 times, not by different variables. All right, so guys, the first thing I need you to do is I've given you 9 equations or functions. You have to determine, by definition, can we call them a linear equation or function, or are they non-linear, all right? So basically, you're looking for y equals mx plus b. That's the form you want to be in. All right, so look at the first one. What if they gave you the function f of x equals 3x plus 5? Well, guys, hold the phone. When you talk about f of x, who's f of x? That's y equals 3x plus 5. Is that mx plus b form?
yes.
Is that a linear equation then, or a linear function? Yeah. Yes. That's as nice and easy as an equation is going to get. All right, what about the next one? What if I gave you p of x, the function p of x that equals x to the third plus 2? Is that a linear function? No. Who's ruining it? Why is that not a linear function? The exponent. You can't have an exponent on a variable bigger than 1. The minute they give you x squared or x to the third or x to the fourth, you are no longer degree 1. You are no longer linear. This is non-linear. All right. What about C? Y equals -4 plus 7x. Guys, could you do a little switcheroo and say this is y equals 7x minus 4? Yeah. So is that mx plus b form? Yeah. Is that linear or non-linear? Yeah. Linear. That's beautiful. Nice and easy and basic. All right, what about D? H of x equals 1/2 times x minus 3. Is that mx plus b form? Yeah. That's exactly what it is, right? So is that linear or non-linear? Linear. And guys, you're going to have like 8 homework questions just like this. You're going to pick linear or non-linear. So you're going to buzz right through them. All right, what about the next one? Y equals x squared minus 4. Is that a linear equation or a non-linear equation? Why is it non? Who's ruining it? The square. You can't have an exponent higher than 1 in a linear degree 1 equation. This is definitely non-linear. Guys, technically, the highest exponent here is 2, right? That's what we call quadratics. That's the next kind of function we work with. We're going to spend this chapter and next chapter working with linears. The next function are the x squares, the quadratic functions. All right, look at this one. This one's wild. This is a function where you can plug 2 numbers into it. You can plug this number in for x and the next number in for y. And when you plug them in, this is what happens. Guys, is this a linear function if you're timesing x and y together? This is non-linear. That is not basic. That is not super, super simple. Get it out of there. That is not mx plus b form. All right, look at this one. Look at G. F of x equals 3 divided by x plus 2. Is that linear or non-linear? Who's ruining it? You can't divide by a variable. The minute they want you to divide by x, no go. That is not simple. That is not linear. Okay. And then this one, I'm trying to kind of trick you. It says y equals 4x. We're trying to look for that mx plus b form, right? So guys, this is y equals 4x. I could put plus 2 that is assumed to be there that represents nothing. 0. So technically, is that mx plus b form? Yeah. So is that linear or non-linear? Yeah. Linear. Nice and easy. All right, and then the last one. All right, now guys, think about your warm-up. Your warm-up look just like this. Were you able to solve the warm-up for y and get something that looks like y equals mx plus b form? Yeah. So this may not look like y equals mx plus b now, but could you solve this for y and get it to look just like that? Absolutely. And it's got everything met, guys. It's got x and y, degree 1, no x squareds, no other exponents. Is that linear or nonlinear? That's linear. Okay, so what's going to happen? When you are given a linear equation or function, guys, there's two ways to give it to you. They can give it to you like y equals mx plus b, just like that, y equals 3x plus 5. That's what we hope for. Or they can give it to you like this one, where it's not solved for y yet, but it's still a linear equation or function. So those are the two different forms that we're going to see these equations or functions written in. Either y will be solved for already, or we'll have to do it ourselves, okay? All right, I also said that if you are a linear equation or function, then when you go to graph it, the graph always makes a straight line. So you should be able to look at any graph and know, number one, if it's a function, if you know it passes the VLT, but you should also know, is it a linear graph? Meaning, as long as it's a straight line, you can classify that as a linear graph for a linear equation or function. So let's practice that now. Now this is where you have a typo on your notes, guys. I think on your notes, I've already taken off of mine. I changed the question, but then I forgot to erase something, and then I made copies. So on your notes, right under example 2, doesn't it say, for example, these are all, let's say that, cross that whole sentence out. I was originally just going to give you a bunch of examples of what a linear graph looks like, but then I didn't. I decided to give you a whole mix of graphs, and we'll decide which ones are linear or nonlinear, but I forgot to erase that line, so I apologize. So just, if there's, whatever is written underneath here, when it says, for example, these, just get rid of that sentence. All right, here we go. So guys, I've given you a bunch of graphs. Some aren't even functions. You have to tell me whether it is the graph of a linear equation or function or whether it's a nonlinear. Guys, the trick is, if it's linear, it should form a perfectly straight line. All right, so look at example 1 right here. Would this be a linear or nonlinear graph? Guys, look at that beautiful straight line. That is linear. That is as y equals mx plus b as it gets.
How?
All right, look at the next one. Oh, a circle. It's not even a function. It doesn't even pass the VLT. Is that a straight line?
Yeah.
No, it's not a straight line. So is this linear or nonlinear? Very nice, Daniel. All right, look at the next one. Guys, is this a perfectly straight line? So is that a linear or a nonlinear graph? Nonlinear. I'll give you a little hint. When we come back from Christmas and we work with the next kind of function, this degree 2, this x squared, this quadratic function, that's the graph he makes. These are the graphs you'll be making after Christmas. All right, look at the last one over there. Is this a perfectly straight line?
Yeah.
So is it linear or nonlinear? It's linear. Guys, he's technically a loophole. He's linear, but is that a function?
No.
He fails the vertical line test.
He is a vertical line.
Right? X, the same X value spits out this Y and 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 this Y. This one X value spits out every single Y on the entire coordinate plane. So it's linear for sure, but it's only a linear equation that defines him. It's not actually a linear function. And guys, you don't got to get that technical. We're just looking for lines, linear or nonlinear, but just to give you an idea. Look at this guy, linear or nonlinear? Guys, we call this the roller coaster. It goes up, it goes down, it goes back up. We actually get these graphs from higher degree functions, like x's to the 3rd, and x's to the 4th, and x's to the 5th. We'll see these graphs in chapter 5, but it's definitely non-linear. That's not easy and nice and straight. All right, what about this graph? Is this a linear or a non-linear graph? Totally linear. What about this guy? That's linear. And then the last one, is it linear or non-linear? Non-linear. That's actually, guys, the graph of an absolute value. Absolute value graphs make the V. Go ahead, Bianca.
Why do only the linear ones have arrows on the end?
I don't know, because I got lazy when I draw these ones. Because, I'll tell you why. Because the little thingy-majigger that I could use wherever it is for insert, the lines automatically had arrows on them, but the curved ones didn't.
I thought like lenses.
No.
Oh.
I mean, these go on forever too. Maybe I should have put them. It's just the little symbol that I used. All right, but good observation. All right, here we go. So guys, technically, that's what you're gonna do on your homework. I'm gonna give you equations, and then you're gonna tell me whether they're linear or nonlinear. And then I'm gonna give you graphs, and you're gonna tell me if they're linear or nonlinear. And then the only other thing I asked you on the homework is, so guys, when you are working with these linear equations, there are two different ways they can give you a linear equation. They can be written in two different forms. One form is everybody's favorite, which is the definition, y equals mx plus b. So when you are given a linear equation, it might be given to you already in y equals mx plus b form. And we love that. If they don't give you a linear equation in that form, in slope-intercept form, then they're going to give it to you in what we call standard form. And standard form is going to look just like the warm-up, where x and y are going to be on one side, and it equals a number. So we call that ax plus by equals c, where a, b, and c represent numbers, constants, that it will be replaced with. And that's how it'll be set up. X and Y are on one side, and a number's on the other. So guys, for example, the warm-up was given to you in standard form, like this. And then I asked you to solve it for Y, which means you converted it to slope-intercept form. But both of these are linear equations, just written in different forms. All right, so truthfully, I feel like in Algebra 1, you always hoped for this form. You always hope for y equals mx plus b, because then you could graph it. You could get the slope, you could get the y-intercept. When it was written in standard form, they usually make you solve it for y and then graph it. All right, so guys, the next example just says these are all linear equations. These are all linear equations. Just tell me which form they are in. Are they in slope-intercept already, good old y equals mx plus b, or are they in standard form? Guys, if you look at example A, is this a linear equation in slope-intercept or standard form? That's standard form, right? X and y are on one side, equal to a number. All right, what about B? Is that slope-intercept or is that standard form of a linear equation? That's our baby, y equals mx plus b. All right, what about C? Is that slope-intercept or standard? Ooh, standard, you have to solve that one for y. All right. What about D? Is that slope-intercept or standard? Slope-intercept. They got y by itself for us. That's our favorite. He's in y equals mx plus b form. All right. F of x equals negative 3x. Couple things. Guys, f of x is the same as who? Y. It equals negative 3x. I could even put plus 2 if I wanted to. 0. So is that in slope-intercept or standard form? Slope-intercept. And then last, is that slope-intercept or standard? Standard, right? Y ain't by himself. Okay, so those are the two ways that you're going to be given a linear equation. I am not going to lie, I forgot to put that type of question on the homework. So you don't have homework questions on that. I'd like to believe you already know the difference, and that was enough practice right there. All right, so what I want you guys to do to practice, because this is on your homework as the last type of question, I want you guys to solve these for Y right now. I'm going to give you a head start. You already did it in the warm-up, but guys, in the warm-up, I said solve for Y. Now I can give you fancy directions that say convert each linear equation in standard form to slope-intercept form. So now I can change the directions up on you. But at the end of the day, it still means solve for Y.
I got an 18 out of 20 in my chem.
You did? And you were worried.
Which one was
I took that was one on Monday.
that? Other one.
Oh, you can get the I
Y'all heard me?
What did you get?
I got well, your
They give you a little bit of a head start. Watch your signs, guys. That's usually one of the things I remember you guys kind of maybe messing up is don't lose your signs. Don't forget to reduce because Delta Math will definitely mark you wrong or reduce or not reducing.
No problem.
All blue is your signs. Now remember, I try to train you guys to put the x's first, right? Because you can't take a -12 and minus 2 x's from him. They're not like terms. So I tried to get you guys in the habit of putting the x's first and the number second. So you're in that mx plus b form. But I can't mark you wrong if you put -12 minus 2x. You're not wrong if the order is different. All right, and then the last one, if you guys remember when we were doing these in chapter 1, I tried to convince you guys to put the 1 in front to be helpful so that when you got to the division step, you didn't make any silly mistakes. Right? Divide by 2, divide by 2, divide by 2. The only thing I worry about is sometimes when students don't put the 1, somehow when they go to do the division step, they get this. Somehow that 2 makes his way to the numerator. No, remember, it's the number in front of x that gets divided by that number that you're moving over. So it's a -1, that's who you're dividing by 2, and it doesn't divide and it doesn't reduce. So you get -1/2 times x and then plus 5. So I always think it helps to put that 1 in front. All right, how many of you guys are okay? Everybody good? All right, so again, you should hear the word linear and you should be like, oh my God, linear is easy. We're good with linear. We start getting to these higher degree functions later on the year, these x squared, these x to the third, it gets more complicated. Enjoy linear. It's easy and it's basic. All right, well, I figure what better way to end than by seeing a linear word problem function. I know, I couldn't deprive you guys. But guys, do you remember when we were doing the word problems and it was like the perimeter ones and then the work ones, like this guy doesn't need hours? The third type of problem was the linear equation ones, where like a plumber charges you $60 as an initial fee plus $5 per hour. That was like what, 60 plus 5x? You were writing linear equations then. You were writing y equals mx plus b equations. All right, so look at this one. This one says the growth rate of a sample of Bermuda grass is given by this function. So they're measuring Bermuda grass. It's a type of grass. F of x equals 5.9x plus 3.25, right? Y equals mx plus b, a nice linear function. Where f of x is the total height in inches, x days after the initial measurement. Guys, I highly recommend when you are given a function word problem, put it into perspective. Who's going into this function and who's coming out of it? So guys, we know how machines work, right? Who goes into the function? X. There's some type of written rule, right? In this case, it's 5.9x plus 3.25. And then who does the function spit out? 1. Or sometimes we can call y f of x. Okay. So we know x goes in and we know y comes out. But this is a situational word problem. So who is y representing and who is x representing? Well, guys, it says where f of x, which is y, is the who? Height. So that means height is who comes out of this function as y. So height is what the output represents, the height of the grass. Then it says x days after the initial measurement. So x is represented by who? Days. So days are who you plug into this function, and the height is who the function spits out. That way when they start talking about 4 days from now, you're like, oh, 4 days? Days is x. X is 4. So you know who to make it. Are you making it an input, an x value, or are you making it an output, a y value? All right, here we go. So part A says, how tall is the grass initially? So guys, before this all started, how many days went by? Didn't even start yet.
X days.
Well, x is days, but how many went by if this didn't start yet? 0. So that means initially means nothing passed yet. No days have gone by. So initially, let the number of days be 0, let x be 0, which means plug 0 in. So find f of 0 to find the initial height of this grass. So the initial height will be, well, what's 5.9 times 0, and then plus 3.25. Right, that's 0. What's 0 plus 3.25? So that means the grass initially starts, when they started all this, the grass was already 3.25 inches tall. So that's the initial height of the grass. Part B says, well, how tall is the sample of grass after 3 days? Guys, if they just gave you a number for days, did they give you a number for the X or did they give you a number for the Y? X. They're saying let X be 3. So if 3 days, let X be 3, which means plug 3 in. Find F of 3. So F of 3 would be 5.9 times 3 plus 3.25. So 3 days after all of this started, they go measuring the grass again. Now how tall is it? 20.95. Thank you for whoever said that. Inches. Nice. So it's going pretty quick. All right, last one. Part C says, now let's wrap our head around this. If the Bermuda grass is 50.45 inches tall, how many days has it been since its initial measurement? Well, guys, 50.45 was given to you as the what?
Why?
As the Y, the height. You know the height. You know the output. They asked you to find out how many days. And who was days? X. So guys, we are trying to figure out what X equals. We don't know how many days went by. But we know the height, the output was 50.45. So it's saying this. Somebody went to this function. They plugged in some number for days. We don't know who, but we know the output, the height, was 50.45. So in order to find X, you have to figure out what number went into this rule to make that number come out. So what do I do with the rule and that height? Set them equal. When does the rule equal the 50.45? Oh, hold on. I'm getting a little ahead of myself here. I'm pretty sure I'm on camera. All right, set it equal to the 50.45, and now you're solving a nice, simple equation. Okay? Minus the 3.25, and you get 47.2. Divide by 5.9, anybody find out how many days? 8 days. 8 days have passed in order for the grass to get to a height of 50.45 inches. So again, I am never too old to draw this picture. You know X goes in and you know Y comes out. They're going to tell you who X is, so put that up there so you know who's representing X, and they're going to tell you who Y or F of X is. Put it there as the output so you know when they're giving you an input or an output. Okay, all right, are we okay? Yes?
Yes.
All right, so here's the thing about your homework. Guys, I made you a homework on Delta Math. However, Delta Math didn't have the exact type of questions I wanted for you guys. So for the first time ever, I made up my own questions on Delta Math. And from all that I've seen, it works. But here's the thing. For 16 out of the 18 homework questions, you're literally picking linear, nonlinear, linear, nonlinear. So I had to make it, you only get one shot. Because if you picked linear and got it wrong, then all you had to do was go back and pick the other one, nonlinear. And you wouldn't have had to put any thought into it because you could have just picked one and gone back and picked the other one. So in order to make you put thought into it, you only get one shot on those problems. So you don't get a new question, you don't get a chance to make it up. It's one and done for 16 out of the 18 questions. I don't think you're going to get a lot wrong, so it shouldn't matter. But I couldn't make it have options because it just, you wouldn't have had to think about it. Yes.
If you get it wrong,
It's wrong.
guarantee 100.
You cannot get a guarantee 100 on this one.
So if you get it wrong, you can't do otherwise.
I know. But hey, it's literally, it's just like the word, it's just you're picking whether it's linear or non-linear. So I would have your notes right next to you because I have given you an example as to every single one that's on there. Go ahead, Joe. Yeah. All right, now homework, like normal, it's due tomorrow night, but guys, I'm telling you, it takes about 5 minutes. That's it. So if you wanted to try to do it, I bet you could get it done. It's all, you got to go through Clever to get to Delta Math.